So we're going to return to the house heating problem, okay, but just focus on house 1. And now I imagine we've got the temperature outside, the average temperature outside on a day of the year. So when D is 0, we're on at the beginning of January 1st, and then we move on throughout the year. So we'd have a function defined like over from 0 to 365. We could think, for example, that function could be something like this. It's T of D, to temperature as a function of day, would be minus 1 over 7, D minus 100 plus 20. I'm just sort of making that up. I've tried to create something that could make some sort of sense. Although temperature is more cyclic in terms of the seasons, but that would be a more complex function. So I thought I'd just look at something that goes up and back down a little bit. Remember, we know our function C1 of T, which is the cost per day for heating house number 1. Okay, and maybe let's focus on a day of the year, maybe the T of on the 30th day, so somewhere like the end of January. If I calculate T of 30, I would just replace D by 30, and I would get, if I do this, you evaluate this, what do you get? You get minus 1 over 7. This is absolute value of minus 70 plus 20. So this is minus 1 over 7. Absolute value of minus 70 is 70 plus 20. And this ends up being minus 10 plus 20. So 10. So clearly we're not in Quebec. We'd be somewhere else. So 10 degrees Celsius would be the temperature outside at the end of January in average. Okay. So how much would it cost to heat the house on that day? Well, clearly I would replace the temperature on that day into C1. So let's write that down. So the cost to heat house 1 on that day is, well, what is that? It's C1 of 10, because that's the temperature outside, okay? And well, I didn't write down what C1 was, so recall here, maybe what I had chosen for C1 was, do I have it here somewhere? Yes, minus 2/3, T minus 20, okay? So I will replace T by 10. So if we calculate this, we're going to get 20/3, which is approximately $18.66 on that day, okay? So let's take a closer look at this. What have we done here? We've started with the day of the year. We've process that data into function T to get the temperature. So what came out of this was 10 degrees Celsius. So that was T of 30. Then we took that and we processed that information into another function, which is C1, to get the cost. And what came out of it was $18.66, and that was C1 of T of 30. So T of 30 became the input, so the output of a function became the input of another one. So we fed that input into C1 to get another output, which was 18.66. This is called composing functions. So when you have like a chain like this of functions, and the output of a function becomes now the input and another one and maybe another one, like it could maybe have like some other function that would process that cost. I don't know, it would be how I don't know, you could from this try to figure out like how much it has cost you to heat one particular room of your house, and you could divide that cost by the or take a portion of it in relation to how big that room is in relation to the rest of the house. So you could feed that information, like that cost, into another one, and then you'd have like a chain of a function like this. So by getting the output every time, the new output, we're composing functions. So this is called a composition of functions. So here I have two, but like I said, you could have more. So in general, what has happened here, okay, we can feed a d into t, into function t. What comes out of it is t of d. And then we can send that into c1. And what comes out of it is c of t of d. So this is the cost to heat the house on a given day of the year. Okay, so it gives you a new function. Okay, a new function of d, because d now is the input. I could so maybe I'm going to show you the notation. That new function, that composition of function here, we would call c1. You have to put a full dot, so c1 dot t. Okay, so is the composition of c1 and t. Okay, and the idea is that c1 dot t of d is c1 of t of d. So it's a new function. Okay, so it's a new function of so a new function of d, which gives here the cost to heat the house, not in function of temperature now, but in function of the day. And in this world, there are a lot of functions that are like that. For example, you could say like the amount of food you're going to eat is a function of your weight, but then weight is a function of your age, maybe. Okay, so ultimately, how much you eat is a function of your age. Okay, so but in the middle, there's the weight that's involved. So a lot of things are like that. So here, maybe just to finish it up, like what would be find a formula for c1.t. Well, let's do it. c1.t of d, this is the formula we're looking for, is according to the definition c1 of t of d. So that's c1 of, now let's calculate t of d. T of d, we have a formula for it. It's 1 over 7 absolute value of d minus 20. No, d minus 100 plus 20. Okay, so this thing here, that's our t of d. It becomes the input to the new function c1, right? So right now we're here. We've got this t of d. We're going to feed that into c1 to get the output. Okay. Now what's c1? C1, remember, it's of if I have a temperature, because that's a temperature here, right? This is a temperature that we get out of this. Right, this is a temperature. The average temperature on that day. C1 of t, so if we're given a temperature, we've got the formula. It's, and I lost it again. minus 2/3 t minus 20. So now we've got an input which in temperature, so we need to replace that input into the formula. Okay, so this is what I've been telling you. You can pretty much replace anything you want in that square to get what the output is. So I tend to use squares like this because it shows really students you can put anything you want in there. So I can actually put 1/7 d minus 200 plus 20, and then I have to do this exact same thing here. 1/7 d minus 200 plus 20. Okay, so that's going to help me get my formula. So my formula is going to be minus 2/3, and then I'll put brackets, like double brackets like that. Minus 1/7 d minus 200 plus 20. No, it doesn't end with this. It ends with bracket like this, minus 20. Like this. Okay, and I could just expand this, so distribute the 2/3 essentially like this, and inside what do I have here? I have got well, actually I've got, you see, after removing the brackets, I'll have 20 minus 20, so that's gonna, well, maybe that's gonna simplify to well, that's going to cancel out and just give me 0. So the formula that I wanted is right there. So that's my function. That's my formula. Okay. I could also calculate something like t of C1 of d, but that would make little sense. That would be what t of C1 of d. In this context, it makes no sense because this C1 of d is C1 is a function. It needs to take in like temperature and not the day of the year. So this would sort of be undefined in my problem. But if I'm given two arbitrary functions, I can actually calculate the composition and get something that's different depending on the order in which I compose the functions.